In this example, which is actually from my notes, I have this curve, which is x plus y cubed minus y equals 1. And what I want to actually talk about is how many points there are on this curve at the value x equals 1. So typically, when you have a function, right, so let's think function. When you have a function, every x has one y. Every x has one y. That's when you have a function. Okay. These are curves, and if you actually type this in just as you see it, this equation in Desmos, what you're going to see is we do not have a function. It's going to bend back on itself, okay? So we might have something that looks like this, okay? Or the reverse, or whatever it is. My point is that this is most definitely not a function because it crosses more than once. However, we still want to talk about the slope of this curve. This curve exists. It's not a function, but it's still special. Okay, so one of the things that we can do is that if we wanted to know, for example, when x equals 1, how many points are on this curve at x is 1. So how many points are on this curve okay? Well, how we can answer this, there's two ways to answer this. One is that you could graph it into Desmos and see how many spots you see at x is 1. So I would find x is 1, go up and down and see how many points we have, okay? The other way you could do it is just old school, plug in x is 1 into this equation. And what I'll get is I'll get y cubed minus y equals 0. And this we could actually solve by factoring. So if I went ahead, factored out a y, I would then get that y is 0. I'd also get that y squared minus 1 is 0, which would be the same thing as y equals plus or minus 1. So according to the algebra that I've just done, there's actually 3 points on the curve at x is 1. They are happening at x is 1, y is 0. Okay, that's this guy. And then they're happening at x is 1, y is 1, and x is 1, negative 1. So there are 3 points on this curve. Now, if I wanted to find the tangent line at all these points, I would need two things. I would need dy dx for this, plus I would need to then do it 3 times. So I'd want to find the tangent line at 1, 0, then at 1, 1, and then at 1, negative 1. So each time it'd be very repetitive. I'd need to go ahead and do that. Okay, let's talk about what the derivative looks like for this guy. Okay, so let me erase this. All right, so let's go ahead and find the derivative of this function. So here, if I take the derivative with respect to x, I'm going to get 1 plus 3y squared dy dx minus 1 dy dx equals 0. Okay. I'm going to move this one to the other side and factor out a dy dx. So dy dx times 3y squared minus 1 equals negative 1. dy dx will equal negative 1 over 3y squared. Okay. Beautiful. Okay, now, earlier I was looking at those points, so we could find the tangent line, the equation's tangent line at 1, 0, 1, 1, and 1, negative 1. However, that's not what I want to do right now. I want to ask the question, does this curve ever have a horizontal tangent line? Okay, so in order to have a horizontal tangent line, you have to have the slope equal 0. And for fractions, that can only happen when the top equals 0. Okay, so can this top ever equal 0? Can negative 1 ever equal 0? No. So here is a curve where this never happens. Okay, now what about vertical tangent lines? Vertical tangent lines are where the slope is undefined. Okay, for a fraction, it happens when the bottom equals 0. So does that ever happen here? Sure, I could set 3y squared minus 1 equal to 0 and solve it from there. So I'm bringing this up because as we go further into chapter 3 and into chapter 4, they'll ask about things like, when do we have a horizontal tangent line and when do we have a vertical tangent line? Okay, so this is horizontal and this is vertical. And oftentimes your equations will involve fractions. So in order to get a horizontal tangent line, the top has to equal 0 in your fraction, and to get an undefined one is when your bottom equals 0 in your fraction. All right, good luck. I hope this helps as you work through the homework.